Good. Welcome everybody to this combined CEDA Dmacc IRO session. A special welcome to all our CEDA members. Usually we have an annual IRO CEDA meeting. In this case, we can combine it with Dmacc to have a session on marine energy. I hope everybody's doing okay, being healthy and staying safe in these strange times. It's good to see that so many of you have tuned in. You all are being muted by the director, so sorry for that, but maybe later in the chat that we can unmute you if you have a question. In the coming hour or so, we will try to inform you about the potential of marine energy as an essential element of the future energy mix. Questions like, what is marine energy? What makes marine energy unique? What are the pitfalls of developing marine energy? And what opportunities does marine energy offer to you will hopefully be answered this afternoon. Before we start, it's good to get an indication of how familiar you are with marine energy. Therefore, we have a poll question for you, Niels, if I may ask you, which appears on your screen right now, probably in the middle. The question is, are you familiar with marine energy? And you can choose from 4 answers. You will see them in the screen. I see it in the screen, so probably you will see it as well. And well, let's see what the results are. I'm very curious. In the meantime, I would like to introduce my co-host in this session, Benjamin Lehner. He's the Business and Innovation Advisor of Dutch Marine Energy Center. Probably a lot of you know Dutch Marine Energy Center. It is the Dutch accelerator for marine energy solutions dedicated to making marine energy the next big thing in energy. So, Benjamin, let's see what the results are.
Very exciting.
Can we see the results, Niels? Thanks. So that's, let's say, 2 things that are quite obvious here. Yes, I've heard of it. That's a small majority, 55%. But there's also a great group that is actually currently working with marine energy. Well, maybe you can elaborate a little bit on that after I introduce you. We will hear from Benjamin in a few minutes. He will give us an outline of the general characteristics of marine energy. After that, we will have 3 guest speakers who will join us online. And let's see if it works. Yeah, it works. We will start with Maarten Berghaud. He is the Director of Project Development at Sea Current. The second online speaker will be Ramzi Neme, the Project Manager of SBM Offshore. And finally, we'll close off with Richard Parkinson, the Managing Director of Inyanga Marine Projects and Hydrowing. Before I hand over to Benjamin, let me encourage you to use the chat function. It's at the bottom of your screen. We will closely monitor the questions coming in, and we will try to tackle them as much as possible during the session. So don't hesitate, use the chat function, and I will closely monitor that. To round off this intro, we have another poll question for you. The second one, Niels. Thank you. The question is, do you think marine energy will play a significant role in the energy transition? 3 answers possible, and let's see what the results are. That's also something for you, Benjamin, maybe to further look into.
Maybe to change opinions.
Yes. Results are coming in. Well, that's promising result. 65% of you thinks that marine energy will play a significant role in the energy transition. Up to you, Benjamin. Can I give you the floor? And please tell us more about marine energy.
My pleasure. I have to convince 11% after all, and 34% who are undecided yet. but I guess the 11% will be the more difficult one. So thanks a lot, Dirk, for the short introduction to my presentation, which will be on the screen in a second. As Dirk already said, I'm at Dmacc, at the Dutch Marine Energy Center, an accelerator for marine energy solutions, and I'm a business and innovation advisor. And now you should see my slides. And I have the very big pleasure to represent Dmacc today on this event. And if there are any questions regarding the presentation, regarding marine energy in general, or anything in the sector, please feel free to reach out to me. You see my contact details now, and you will also receive them with the follow-up email where you see also the recording of this session. But let's take a step back and let's start actually with the energy transition. Let's start with the transition to renewables. And I think what we really strongly see the last couple of years is that this transition to renewable energy is unstoppable. We have the numbers of countries who have clear renewable energy targets quadrupled between 2005 and 2015. And we see very strong programs from the, let's say, the biggest economies in the world, from President Biden with the United States, China. China, actually, an interesting fun fact, they deployed so much wind and solar that there is serious concern if the numbers are not faked, because it is too much to imagine for 2020. So there is an interesting report to read for that if you're interested in that. And of course, last but not least, the European Union. And as all of you might know, the European Green Deal is one of the most ambitious programs to get this energy transition working for Europe. And not just wind and solar, but also marine energy is an important part of this transition. I hope this next slide comes up for you as well. Yes, exactly. So marine energy is an important part of this transition. And just a few news items which are very recent, like the first two even from March this year. And these are about new wave wind parks planned in Ireland, for example, with Simply Blue Energy, or a wave park planned by EWP and EDF in Israel. And of course, there are also many tidal projects. I have here just a small picture of Orbital Marine. And these are just some small examples, but if you think about what is going to happen in this sector, it's huge. We see a lot of large-scale devices hitting the water in the next 1 or 2 years. And these are great news for the energy transition, but also especially for the sector. So I have here a selection of some large-scale devices, which are partly already deployed and partly will be deployed the next upcoming months or years. And we are very proud to be part of this transition, of course. And not just the industry is showing a strong way forward, but as I mentioned before, also policy does. On this small map, you see now how different countries around the globe try to shape this policy shift for marine energy. And a particular good example are in terms of subsidies, how China has a feed-in subsidy for tidal technology, or how the US and Canada have direct subsidies for marine energy. And also very interesting is this very ambitious goals in the European Union, in the UK, in Indonesia. Indonesia plans to deploy 3.1 gigawatt actually by 2025. Europe plans to deploy gigawatt scale by 2030. So there is a lot going on in this sector, and it's very important that we all work together on helping to make these targets, these policy targets come true. So now I talked a lot about why it is important, but I didn't talk yet what is actually marine energy. And I think that's very important if we want to keep this conversation ongoing. So in general, we have 4 different types of the core technologies in marine energy. And these 4 technologies are the wave energy. Wave energy really meaning we extract energy out of the wave movement in the ocean. Then we have tidal energy. Tidal energy uses the gravitational effect between moon and, the tides are based on the gravitational effect between moon and earth. And tidal energy harnesses this energy on this very predictable and for a long-term predictable source. We have Otec, ocean thermal energy conversion. And this ocean thermal energy conversion is really the extraction of energy or electricity out of two water bodies, one hot, one cold. And it's a perfect example how you can use or produce electricity inside the tropical area and the equatorial area. And last but not least, for this really core marine energy technologies, we're having salinity gradient. And salinity gradient, again, uses two water bodies. In this case, not temperature-based, but based on their salinity. So a saltwater water body, a freshwater water body, and it does exactly the opposite of a desalination plant. Instead of desalinating the water via electricity, it salinates the fresh water a bit and removes ions from the salt water and therefore produces electricity. So these four form the core of marine energy. But we also have very good friends in the same sector. We have the friend of floating solar, which we're working with a lot, and has very similar challenges like the marine energy technologies right now. And we have our good friend floating wind, with whom we also have many projects ongoing and work on. So that's marine energy. And where can you find marine energy? The question, first of all, why marine energy? What are the unique selling points? I was a bit ahead of myself here, because these are just so familiar to us, and it's always good to remind ourselves why we're actually doing that, why we want to push marine energy forward. First of all, it is renewable. I mean, that's pretty clear. It is a renewable source of electricity, which is not dependent on any kind of fuel. The fuel is the gravitation. The fuel is the basic wind, which makes the waves. The fuel is the energy stored in the ocean. But also, they are very reliable. We can predict these energy sources for decades if it's about tidal, or for weeks for waves. And this makes it a very nice addition to wind and solar because of their predictable and reliable character. They can help us to balance the grid in a very powerful way, because as many of you most likely know, water has a much higher energy density than air. And therefore, with the same area, we can extract much more energy than in wind. So putting a tidal turbine in there could extract much more energy than wind. In theory, we just have to show that. And besides that, all these technologies, all these marine energy technologies are mainly invisible to the public. And that's something we see with the wind industry as a big problem right now, that nobody wants it in his backyard. Nobody wants to look at the wind turbine. But for the marine energy devices, they are hidden below the sea surface, or they are just like a ship on the sea surface. And last but not least, they are very scalable. So, and that brings me to the slide I wanted to show you even before, which should demonstrate or should let you see a bit the potential of marine energy around the globe. I know these four maps at the one slide might be a bit small, and also don't be worried, I don't give a weather forecast now for the marine energy sources, but it shows you a bit the global distribution and the total potential of marine energy. Global distribution means not every source can be found everywhere, and potential, not every source has the same type of general potential. So as you can see in the first frame of this picture, which shows the worldwide potential for tidal energy, is about 0.5 terawatt, so 500 gigawatts. And it is to a big part in Canada, Russia, Southeast Asia, but also in Europe, especially in the UK and France and Argentina. So that's kind of the areas on the world where you expect tidal and where tidal projects make the most sense for the future. But also in the Netherlands, there is a good tidal potential which we should utilize. Same for the wave energy. The wave energy has even more overall global potential of 5,000 gigawatts, so 5 terawatts. And you see that especially the European west coast, so the east coast of the Atlantic, so to say, has a very high potential, and the west coast of the United States, as well as Australia, New Zealand, and Argentina. In the bottom right, or bottom left actually from the view of the screen now, you see the salinity gradient potential. Also, salinity gradient has 1,000 gigawatts of potential, so a huge potential out there. And basically everywhere where a river goes into the sea, there is a potential for salinity gradient electricity generation. And last but not least, again, the Otec potential. And here you see very nicely that Otec is limited, but has a huge potential, but limited to the equatorial belt and the tropic area. Why do I show you this map? Because for many of you doing supply chain, doing international business, you can now select based on that where your next business arrangements might be. Let's go on that. So I said already, marine energy is rapidly growing. And just to give you a bit of a feeling for numbers, I mean, we always talk about LCOE in the renewable energy field, and we always talk about the potential of it. But how did they develop, and how are we foresee them to develop? And in the left graph, you see the large potential of the European Union, basically, over the next 30 years, where we, with a feed-in tariff, can deploy terawatt hours per year already in 2030, so 8 terawatt hours, and reach up to 260 terawatt hours per year, and a general market size of 16 billion euros alone in Europe for 2050. So this is a huge market we can tap into. And going back to the slide I was presenting in the beginning with the policy incentives, about 40 gigawatts is directly planned by the European Commission to be deployed by 2050. So this also represents this huge market here. Also, the LCOE will become competitive. I don't go here now step by step through all the LCOEs, but just to have a certain number in the top of your head. For Europe, we expect the tidal hits in LCOE below 100 euros per megawatt hour by 2030, and wave hits one below 100 euros per megawatt hour by 2035. 2030, 2035, it sounds far away, but if you think on the duration of projects and how long they take, it is actually just around the corner. And this LCOEs of 10 cents per kilowatt hour or 100 euros per megawatt hour are very competitive, especially given the potential and the reliable nature of these sources. And besides also the potential of the marine energy, I'm waiting for my next slide. Yeah, here it is. There are many different markets where we can work on. So many different markets which are suitable for marine energy technologies. We have, of course, we can energize infrastructure. Berghaud made a really nice example here with the Oosterscheldeskering in the Netherlands. Energizing infrastructure, helping coastal protection, and at the same time producing electricity. We can sustain operations. So we can sustain operations at ports. We can sustain operations at offshore platforms. So for all the areas where we need to become more greener, where it is really critical for the upcoming period. We also are looking, of course, into building marine energy farms. And we can talk here, of course, of single-use farms, so really a tidal farm or a wave farm, or of multi-use farms, so really a farm where you have wind and wave together, where you have wind and tidal together, or to remember our friends also, where we have wind and solar offshore together. So there are many markets, also many I didn't mention now, like aquaculture or off-grid solution, island solutions, where marine energy is already on the rise and will be more so in the future even. And I just want to go deeper into two examples, because as Dmacc, we are working very closely on these two use cases, these two markets. One of them is the multi-use of wind. And the multi-use of wind means that we, next to the wind turbines, we also deploy wave, tidal, floating solar in there. By that, we not just improve the business case or potentially improve the business case of a multi-use wind farm by producing electricity in times where there is no wind and by utilizing the electrical infrastructure better. It is also just a better use or a more efficient use of offshore space. And as I guess most of the people in this call are very well aware, there is already quite some problems in marine spatial planning, and that could help us resolve this problem further. Another example I want to shortly talk about is the powering of offshore platforms. We will need oil and gas for quite a while. Oil and gas is important for our transportation section. It is important for our medication sector. It is important for our plastics and polymer sector. So oil and gas platforms will continue to be there, and it's good that they are, but we hope to make them more sustainable and more renewable. And that you will see on my next slide as soon as it comes up. And so one way is, of course, to directly power the platform with marine energy, and especially wave tidal are very well suited for that because they are providing electricity to a much more reliable factor. And also, if we talk about the lighthouse mode for decommissioning, marine energy is a great sector, and we're looking right now in this example, onto this example. And as also is explored already with the Poseidon projects and others, we have marine energy used for offshore hydrogen production, or the potential of using marine energy or other sources for offshore hydrogen production, or reutilizing offshore platforms for that. One very big example for the offshore platforms is Eni, who actually acquired a wave company and is now making a demonstration with this wave device offshore in getting their platform powered. And that brings me actually to one of my last slides. What actually is Dmacc? So I've talked now a lot about what we support and what we stand for, but just to frame a little bit what we are doing, or what we are as an organization, we are, as Dmacc already said, an accelerator for marine energy. We work on several different areas. We work on innovation. We work on finding capital for the companies, working with investors. We work on the policy part. How can we make supportive policy, and we work at markets, and that was I showed before. And we are having a network of more than 75 partners, international partners. We are working with more than 100 marine energy companies, and have quite some public and private funding brought to the sector right now and helping it to mature it. And Dmacc is, as it is, also supported by, that was one too fast, but I can just say that Dmacc is also supported, of course, by a lot of European projects like the OESA project, and then we'll come to the poll question, so just stay tuned for a second. OESA is also co-funding this initiative of this joint webinar now with IRO. And now we come to the poll question. I guess many of you already pressed it, and that's perfectly fine because we want to get as much feedback as possible. So how do you see your role in the marine energy market? And please put a small sign on everyone you agree on. Where do you see yourself being part of this transition? And with that, I also give it back to you, Tjerk, then discuss the outcome of the poll.
Yeah, thank you, Benjamin. For this poll question, don't forget, if you have an other, type in the chat what other, let's say, activity you think for yourself is applicable to be part of this marine energy development. So use the chat for that, so we can also have a look at that. Thanks, Benjamin, for a clear outline of marine energy. I think we can all agree that marine energy has a huge potential. And I think that in the audience, we have a very big variety of, let's say, offshore maritime companies in the audience. They must be enthusiastic about now. So let's look at the results.
I hope so.
Well, it doesn't surprise you probably, a big majority sees interest for themselves in the construction, installation, and decommissioning part. And the chat, let me see, because I see here, there's people saying tidal technology developer, environmental impact, project development and assessment. So these are very good suggestions. We'll take them with us. And I think you will definitely do that, Benjamin, as well.
Definitely.
Okay. Thank you very much for this. I have one question for you, Benjamin. Obviously, there's a huge potential. It's still in, let's say, in its infancy, more or less, marine energy. What is it that you need, or the marine energy sector, and don't maybe dedicate it to the Netherlands, to make a huge step forward? Could you name one element that you need to make marine energy really make a difference?
Yeah, no, definitely. So I think the major factor we need to do as a sector is deploy. We are about there where wind was 10 to 15 years ago. So offshore wind was 10 to 15 years ago. And the only way we can really pressure or get the price down to be commercially feasible, we need to deploy. So every deployment we can arrange with Wave, with Tidal, with also, especially in the Netherlands, would be a huge help. And whenever someone in the sector wants to deploy and just try these devices out, we have a lot of developers who would be eager to try out the devices, or even get European developers to come to the Netherlands to deploy their devices there.
Okay, thank you very much. I have questions for you later on, but we'll do that after the online speakers. I would like to introduce now to our first guest online speaker, which is Maarten Berghaud. Welcome, Director of Project Development at SeaCurrent, a Dutch company. Maarten and his team strongly believes in the power of flowing water. Maarten, may I invite you to the floor? Virtually.
Thank you, Jake. Thank you for introducing me, and thank everyone for taking some time to listen to the story of SeaCurrent. Let me shortly introduce myself. I'm Maarten Berghaud, over 20 years now in the energy sector in various roles and responsibilities. Amongst others, I was Director of Strategic Innovation in Vattenfall in Stockholm, and in that time, I've looked at a lot of technologies in the energy spectrum. And when I got into touch with SeaCurrent, I was really struck by the potential this technology offers, and I gladly elaborate on that in this presentation. But I decided to join SeaCurrent as a co-founder, and I focus on projects, as you mentioned. Why are we doing this? Of course, Benjamin has explained it much better than I will be able to do in this short sheet. But the energy transition is one of the big challenges we have as mankind, and we need to accelerate it. We need more than just wind and solar, as Benjamin also elaborated upon, and also wind and solar face specific challenges these days, which is integration in the landscape. You see a picture of the nice island of Ameland, where we have our test site. And this is how it looks like today. And this is exactly how it will look like when we've deployed our units, which will make it a little easier to deploy than, for instance, wind, which is not allowed in this beautiful open landscape. And the second element is grid integration. So delivering at different times, also delivering in the winter when solar irradiation is substantially lower and when energy demand is higher. That's what Tidal can offer. So let me go to the next slide. It's a bit slow. Oh, I think I skipped one. Don't want to hold you withhold the team for you. Of course, I'm not doing this alone. We will be around 20 people the 1st of April. We've got a couple of new hires joining. We managed this with Yuri, who founded it, and we'll focus on technology. Maurits is focusing on funding and marketing, and I focus on the projects. And we engaged Daniel, who's been working on big offshore operating vessels for 17 years. And of course, the team is dominantly technically orientated to get the new technology ready to work with different discipline engineers available. And also increasingly, we have people focusing on ecology to really understand what is the impact that our device has on the surroundings and on nature. Because being good on that field and limiting the impact is going to be vital to reach large-scale deployment. And that's our ambition, to bring energy to hundreds of millions of people in coastal areas worldwide. Of course, we're not doing this alone. Dmacc is one of the entities supporting us, but there's many more. We cooperate with, for instance, University of Groningen on hydrodynamics and ecology, and also with the Ameland Energiecoöperatie. Together, we tried to deploy the first tidal project near Ameland. SeaCurrent develops the Tidal Kite. It's based on the kiting principle. I'm sure every one of you, or at least most of you, have been on the beach with the kite. And if you have the kite up in the air and you steer it perpendicular to the wind flow direction, then the kite starts moving and it starts creating a traction force. That's exactly what our device is aiming to do also. The kite consists of 2 rows of wings, and if we place a wing in the flow, the kite will start moving perpendicular to the water flow direction and will create a traction force. We utilize this traction force in our PTO, the power takeoff, to convert this into electricity. Of course, we have a mooring to make sure the system stays in place, and a grid connection to deliver the renewable electricity to shore. If we look at the benefit of a kite, it shows in particularly in more shallow areas. The trick of harnessing energy from a flowing mass, as we see every day when we drive on our roads with wind turbines, is to cover as large as possible area perpendicular to the flow direction. And that's the reason why wind turbines get taller and turbine blades get longer. Only if you operate in a relatively shallow water area and you want to extract energy from the flowing water, a rotating turbine is not the optimal way to cover the maximum area. We do this with our kite that is operated perpendicular to the water flow and covers a stroke length of roughly 100 meters, perpendicular to the water flow again. We can return on a different depth if it's deep enough. And what we have is several wings placed behind each other. So basically, we try to harness the energy from the flowing water in a 3D format. And this gives us an advantage in shallow areas over other technologies where we can harvest more energy with one single device. As we cover a substantially larger area, we can also now harvest energy from lower velocity areas. And that in that area where the velocities are lower and where the waters are more shallow, we have a unique opportunity. A short point on the impact on the environment. We've done a lot of research on this. We limit the speed of the tidal kite to 6 meters per second. This number is of course not randomly chosen, but originates from a lot of research done in the Netherlands with pumps and turbines. As you all know, half of the Dutch population lives below sea level, and we pump out a lot of water. And we don't only pump out a lot of water, but also a lot of fish are passing via this water. So there's a lot of knowledge on fish safety that we deploy or that we employ also in our design criteria. We use a biodegradable working fluid, and the University of Groningen has done a lot of research on the impact on the seabed, and with the safe distance we keep, there's no impact. The ability to deploy the systems fully submerged, of course, makes it also possible to deploy relatively close to the land. And that makes grid infrastructure cheaper, and also we use small vessels to deploy and retrieve tidal kite units that we can tow behind small vessels. This is important for cost efficiency and also important for effective working hours that we only deploy, or as much as possible deploy, in the workshop. Last but not least, we have a very positive EROI, energy return on energy invested, comparable to wind turbines and substantially better than solar. Again, a sheet on the market potential. Benjamin mentioned 500 gigawatts. We believe 600 gigawatts is the result of our market research that we can clearly identify, with half of that roughly in low velocity areas where we focus on as a first market. Substantial potential in Europe, but a lot of more potential around. As mentioned, we have an intention agreement with the Ameland Energy Corporation to provide Ameland with renewable energy from tidal kite units going forward. But there's also substantial interest from offshore wind park operators that see opportunities to deploy tidal kite units to extract more energy from the same sea area space. Just quickly zooming in on where are we today. We're almost, we're more than 7 years old, founded in 2013. Developed the concept, patented it, and then started first testing it the Marin flow basins in Wageningen, where we demonstrated we can kite, and we also demonstrated the amount of energy we can extract from flowing water. After that, in 2018 and 2019, we deployed kites from a moored barge on which the power takeoff was placed in a flow channel in the Waddenzee, north of the Afsluitdijk, where we mastered the art of underwater kiting for the first time, and positive results have decided us and also the Dutch Waddenfonds to invest in a full-scale demonstrator, the TRL6 unit that will be deployed later this year near Ameland and deliver the first tidal kite electricity to Ameland. If we look beyond, we need one more step after that in order to get the technology fully ready and certified, and then we're ready for market entry in the Netherlands and Belgium, and are preparing in parallel, of course, a worldwide expansion. We believe that this tidal kite technology has a huge potential worldwide, but I gladly share thoughts with you and your competence and knowledge around the globe on that going forward. So that's the plan for rollout. And in this, of course, we're looking to cooperate with partners who can contribute. We want to focus on delivering the best technology to extract tidal energy from shallow water, low velocity areas. And we're looking forward to partner up with others who are very competent in installation and maintenance, and together bring this great technology further around the globe as the next big thing in Dutch export of engineering solutions with water. Thank you for your attention. I'm sure there will be questions in one way or another, but I leave that with you, Jack.
Yes, thank you, Martin, for this interesting developments. You've been around already for 7 years. Let's see if the audience is also very enthusiastic about your project. So, Niels, if we can have the poll question. Very good, thank you very much. This question actually came from Martin himself. He says, I see opportunities for my company in tidal kite energy projects. Please pick your choice. You must see opportunities for your company in his project. Let's see what happens. Results are coming in. Yep. There they are. Look, that's promising for you, Martin. 20% says yes, short time already. What I would like to do is there somebody, let's say, that wants to elaborate a little on that, who gave that choice to A? Can we unmute somebody? Is there somebody who would like to say something about this opportunity? Can we get that done? No? Everybody's silent. Well, at least, Martin, be aware that there are people in this audience that really see opportunities for them to get involved in your project. So we'll get back to you on that. I have a question for you, Martin. What is it that you, if you were, let's say, to name one element that you would need now to make your project successful within, let's say, 2 to 3 years? What is it that you would need from people, organizations, government?
What we need is a couple of things. Of course, there's always the funding aspect to it. Another thing is what I think everyone sort of preaches, but I hope we will also practice, is learn by doing. There's a lot of, with anything new, there's a lot of skepticism, and how is this going to work in nature, and is this not going to collide with seals and things like that. There's a lot of knowledge on this already, and a lot of convincing knowledge that won't happen. And we gladly or are eager to demonstrate that we can do this in a good balance with nature. So I'm appealing to everyone involved and authorities to say, let's do it and let's demonstrate it, let's show it, rather than to be studying for a very long time and try to be really 100% sure about the impacts.
Okay, makes sense. We actually have 2 questions in the chat. The first one, what does the energy output look like of a tidal kite farm, considering you have high and low tide and you have spring and neap tide?
Yeah, just let me. Oh, I'm not controlling the sheets anymore, but I had a picture on this in the backup sheets.
Okay, maybe you can fix that. Yeah, we will do that for you, Martin. Just a second.
That gives.
Yep, you have control.
Just scrolling through the slides. I hope it stops at the right point. It's a bit slow. But I just wanted to show you the tidal cycle. So this is a tidal cycle of a moon cycle, and the water velocities. And of course, the water velocity is crucial in determining the amount of energy available. The good thing is that moon cycles are very comparable. So this is one moon cycle, and the next moon cycle will follow. So the good thing about tidal energy is that you can design your system exactly based on this. And as I tend to say, if you compare it to wind, there's always wind force 3 or 4, as you can see. So it depends, of course, on how you tune your system. And if you tune it to be operated at maximum capacity at the lowest tidal stream velocities available in this period, then you get a very high load factor. You can get close to 5,000 or 6,000 full load hours. If you tune it somewhere in the middle or higher regions, you end up at 3,000 full load hours. So that's the range what we can do. But it's the production profile mimics this shape. So basically, around the change of the tide, the direction, there is a period of half an hour to 45 minutes where we can't produce. Then the speed picks up and we start operating at part load. And then when the speed is at maximum speed, we operate at full load for 2 to 3 hours. Does that answer the question?
I hope so. We can't verify, but I hope it answers your question. Otherwise, we will send this person directly to you. We know who sent the question in. Okay, thanks a lot, Martin. We'll be back, let's say, at the end of the webinar.
Thank you. I saw some further questions. I will just answer them via the chat shortly.
Very good. Now it's time for a second guest online speaker, which is Ramzi Neme. Right out of his office in Monaco. Ramzi works with SBM Offshore, and actually the renewable energy focus of SBM Offshore is mainly on solutions for floating wind and also on wave energy conversion. Ramzi is here to tell us more about the SBM's wave energy activities. Ramzi, welcome to have you here.
Yes, can you hear me?
Yes, we can, and the floor is yours. Thank you very much.
Thank you, Dirk. Thank you. Good afternoon, everyone. So I will introduce indeed our wave energy converter. But first of all, I will introduce a bit about SBM Offshore. So I'm Ramzi Neme indeed, and been working with SBM for 24 years as in project management, as project managers. And I've joined Renewable product line in SBM 2 years ago. So basically, SBM is a leader in design, supply, and operating floating production units and mooring systems. We have our head office in Amsterdam, and we have a global presence worldwide, with Monaco being the excellence center for renewable product. So here you have indeed key figures from last year. We have approximately 5,500 people, and we have a revenue of 2.3 billion. Our experience is over 65 years, and we are developing projects from scratch, financing to operation. And our, let's say, footprint in renewable is since more than a decade now, and we have two main different products in our portfolio: the floating offshore wind solution based on TLP, and the wave energy converter. So I will introduce to you the wave energy converter right now. Okay, so what is the concept? So first of all, we looked at the conventional technology for wave energy converter, and based on our intensive experience on the offshore product, we come to the conclusion that we need to change drastically the approach for wave energy converter to be more efficient. So indeed, I mean, all the conventional technologies are based on PV structure and therefore high capex, mechanical power takeoff, therefore intensive maintenance and costly operation. The load concentration are based on few power takeoff elements on the systems, and most of the systems are optimized for one wave period, and therefore derive a lower capacity factor overall. Just to mention that the point absorber is exactly what we are used to. Our calm buoy, and we have more than 400 calm buoy delivered throughout the history. So we know quite well this product, and that's why we come to the conclusion that we need to change drastically out the principle. So our principle, and you can see a picture here showing basically how the system will work, is based on very light structure made of silicone. There is no mechanical part, so therefore it's easy to deploy and have a reduced capex. There is no routine maintenance as we don't have nickel parts, and this is also minimizing the OPEX. The geometry is adaptive and enhances the survivability of the system. It's silent, so there is no disturbance, and very easy to very low impact environment. And the bandwidth is large, and therefore with a high capacity factor. So I will explain to you the redundancy in the next slide. But indeed, I mean, the electricity is directly produced from the system, and there is no transition piece. So indeed, I mean, the working principle is based on the principle of muscle, and the tube is a fully flexible tubes filled with water, and it's closed at both ends. And when the water inside is coming into resonance with the wave outside, you have obviously a stretch and relaxation mode on the tubes with the diameter changed, and therefore this is directly producing charge and discharge of electricity. So we have indeed an energy conversion system from what we call electroactive polymer, that is basically the body of the WEC, and the takeoff is directly embedded in the structure. So you can see on the right side of the slide what we call the EAP ring, the electroactive polymer ring, that is basically constituting the tubes, and this electroactive polymer are generating directly electricity at different frequencies when it's excited by the waves. Here I will show you a small film. It's 50 seconds, showing basically how we applied to the silicone material, the bulk material, the electrodes. This is what we have in our laboratory, and I will show you. There is no sound, but I will try to explain to you how it works. So this is the equipment that we built. It took a while to build it. It's a specific equipment. So you have the raw material that is at the entrance of the machine, and we coat the raw material with electrodes on both sides through this machine, and at the end of the machine, at the exit, you get what we have, the raw material for the EAP. So you have basically the silicone with the electrode on both sides, and then you have this collector made from silicon type, and this collector will be connected to the streamer. You put that in the oven, and you end up with the EAP ring that is basically the core element of the WEC. So this is what we are doing in our laboratory close to Monaco, in Nice. Now, where we stand. So obviously, what is important is to move from rigid structure and let's say inappropriate power takeoff to a fatigue-friendly structure and with a larger frequency of production and a large obsolescence bandwidth. And therefore, this is how you end up with reduced capex. And IRO tubes, being in silicone with no mechanical part, is basically light and is able to produce with a large bandwidth. In terms of fabrication, I mean, conventional systems are basically made of steel and are very heavy. They are built in yards. What we have now is something that can be industrialized quite easily and manufactured in a plant. So it's really an easy step to commercialization. In terms of installation, the conventional structure are or need heavy lift devices for installation. Our system is basically transported on rail and can be easily deployed or much more easily than conventional system, and therefore you have a reduced cost for installation. And at the end, as there is no mechanical part, the maintenance is really reduced, and therefore you have a reduced Otec and very limited failure. So this is basically the way to get to a lower cost of LCOE, and this is what we believe is will bring basically a new approach to wave energy converter. So in a nutshell, our system is really flexible and it's have an adaptive geometry. It's silent, approximately 100 tons per megawatt produced with, let's say, the scale 1 WEC, meaning that it's roughly 400 meters long, so 1.4 meter, 4 meter diameter when it's, let's say, fully loaded. We can produce 6 megawatt, no mechanical part, and minimal part impact. So the key benefit at the end, low LCOE, easy deployment, zero maintenance or almost zero maintenance. Production redundancy, I mean, obviously we can produce with different wave frequency. I mean, and this is really a difference in principle compared to conventional system. We have as well flexibility in executing the project. We can indeed have this WEC developed in factories, and the energy is directly converted from the wave to electricity. There is no intermediate pieces, and therefore it's very flexible and efficient. It's silent and obviously limit division impact as it's stand below the water line. So where we stand today, I mean, we have developed, or we are developing the concept for a while already. So we are in a prototype development right now. So from 2009 to 2019, we've developed all the machine and the design required to produce the material. So we are producing now the prototype, and this prototype will be a smaller scale, of course. I mean, roughly it will be 60 meter long and 1.2 meter diameter. We will test it in Monaco area for a year, and this is planned for end of next year. And we will be, after this test, should be ready for pre-commercial project, commercial farm later on around 2026, 2027. And the aim is to get to an LCOE below 60 euros per megawatt hour. So this is where we stand today. So indeed, I mean, the question is quite large. I mean, we are still at prototype level, but we'd like to understand how you could help to support and promote this our WEC system as, I mean, in project development. This is the target for SBM in the coming years. Thanks for your attention.
Thank you, Ramzi. Very impressive developments, as I can see. Maybe to add on this, maybe if somebody wants to answer this question, please do that via the chat so that Ramzi can straight away learn from your reactions. Can we maybe have the question one more time on the screen so that everybody knows.
Yeah, sorry. I was trying to get back to the...
Oh, sorry.
Well, I don't have the control anymore.
No, I understand. I can repeat the question. How could you, the audience, help to support, promote project development with the WEC system of SBM Offshore? So please, if you have any remarks on that, do that via the chat, so then you can directly relate with Ramzi.
Thank you.
Ramzi, I have one other question for you. You all know SBM Offshore from FPSOs and oil and gas. What made SBM Offshore, let's say, go into renewable energy and specifically into wave energy?
Indeed, I mean, obviously, I mean, the initial expertise from SBM is mooring system. I mean, this is where we started in 1954, and we end up being in FPSO business because there were a market at that time. And in 2006, we've decided to start basically investigate other product and more oriented with renewable. So we start with obviously our thinking on the wave, on the floating wind, and so it's all those basically are based on the expertise of SBM of the mooring, and we have a vision that the ocean will provide energy for the generation to come. So indeed, I mean, at large, SBM today are indeed in FPSO and oil and gas industry, but the core expertise from SBM being the mooring and being offshore, it's natural that we have entered for a few years already this new segment for the future generation.
Okay, thank you. Yeah, I think it's a good sign that big companies like SBM and, for instance, also Allseas enter this market of marine energy. Allseas has acquired Blue Rights, and they're into Otec. SBM Offshore is into floating wind, but also into marine energy. I think that's a good sign, and hopefully that will stimulate others also to enter this market. Thank you, Ramzi. Now let's move on to the third but and final online guest speaker. That's Mr. Richard Parkinson. He is Managing Director of Inyanga Marine Projects in Hydrowing. And Hydrowing is dedicated to make their tidal energy converter a success. Mr. Parkinson, can you hear us? Can we hear you?
Yes, I can hear you. Can you hear me okay?
Absolutely. Well, thank you for being here and sharing your story about the Hydrowing.
Okay, excellent. Yes, thank you very much for the introduction. And yes, hi everyone. I just wanted to give you a little bit of a background about our project on the Hydrowing. Firstly, a little bit about our own background and where our journey in tidal energy. I previously founded a company called Mojo Maritime back in 2004. We became a bit of a specialist in installing tidal energy machines. Anybody that's worked in tidal energy will know that one of the biggest challenges we have is deployment, working in high tide races, and that's something we have got very, very used to and evolved over the years. And then 3 years ago, I started Inyanga, and I think one of the aspects of Inyanga was one of the key things I wanted to look at was addressing some of the issues that I felt existed in tidal energy, how we could overcome them, apply all the experience we had gained in the 12 years previous to that from the early stage projects on CGen and the Maygen project and things like that, and what worked, what didn't work, and how we can take the sector forward. My own feeling was that the big challenge for tidal energy is operation costs, and the operation costs, particularly on the larger turbines, is very high. When you want to go and recover a turbine, it can cost anywhere between 700 to 1 million K because they have to come ashore, and that could be very costly and prohibitive to advancing the technology. It was based on this that I developed the HydroWing technology, because I believe passionately about tidal energy and its potential, and I believe that it could be have worldwide potential. Here you have a map showing the distribution, which is very similar to the map shown by Dmacc earlier. So yes, there's very high potential, as we mentioned earlier, up to 500 gigawatts of potential, and billions of 53 billion euros of revenue. So it's a good market. Tidal energy is very predictable. It's the only predictable form of renewable energy. In 2019, December, we acquired, in partnership with QED, we acquired Turbine, which is a Dutch-based tidal energy developer, which had hit hard times. I've always been a huge fan of the Turbine turbines. The key features I really love about it is the bi-blade system. So it's bi-directional with a very simple system that turns with the tides. I think it's at exactly the right scale. Start small, demonstrate reliability, and then improve the technology and scale it up from there. And that's very much the route Turbine has taken. Is very much the route we're going to continue with Turbine. We have three products at the moment on our shelf. We have the T1 turbine, which is the world's most reliable and proven turbine. Some of the turbines we have been running up to 9 years. The T2 turbine, which is currently installed on the Oosterschelde project, which we mentioned earlier, and we have 5 of them on there. We took over the OTP project in December and started operation in February this year. And those turbines are working day in, day out. I think what's reassuring for me is that the turbines are, I can't remember the last time somebody actually had to go down there. They just run day in, day out, completely automated. No need for any intervention whatsoever. We just have a look at them from time to time. And I think this is important to us, because the next step for us is going to be to go from working on sort of storm barrages and platforms to taking this technology subsea. Our third turbine we're developing is a larger scale, up to 400-500 kilowatts, is the T3 turbine, which is in development at the moment and will be our next generation. But our main focus at the moment is on the T2 turbine. We have a commercially ready turbine. It's low cost to produce. We can mass produce it. The turbine fits in a container, can be shipped anywhere in the world, and has demonstrated reliability and is suitable for bankable projects. In 2017, I founded HydroWing and developed and patented the HydroWing device. And the goal is to basically produce bankable tidal energy projects. It's as simple as that. We believe that combined with a Turbine turbine, we believe that we can, within the next 2 to 3 years, produce bankable projects at competitive levelized cost of energy, and can compete with offshore wind and other nuclear power and other forms of power production. We're very confident in our technology. We're using methods and techniques that we use day in, day out. It's a routine operation. And we believe that the devices should be as simple and agricultural as we can possibly make them, as few moving parts, because anything that moves will fatigue and break in time. So that's been the key focus, and that's how we demonstrate the technology. I've just got a short animation here to show you, to give you an idea of the concept. It's always easier to demonstrate the technology with the animation. So basically, we have 2 removable wing structures on a jacket type foundation, which is gravity based onto the seabed. They are staggered so that we have lifting corridors and flowing corridors, so that we can remove the devices very simply, and the devices aren't interacting with each other. We want the turbines as close together as we can, because this creates an effect called the blockage effect, which actually accelerates flow through the turbines and gives actually a higher yield. We can get up to 20% higher yield from this. The wings are wet made connected onto the structure and recovered using a davit system on a floating vessel, could be a barge or a small DP vessel, and recovered to surface where they can be maintained. Our maintenance strategy, which is absolutely key to this, is that the devices will be, we believe in the Formula One pit stop strategy. We have spare turbine on our projects, so we can change a turbine within 2 days. We can ship it from our facility in Wieringerwerf in the north of Holland to anywhere we need to, and change the turbine. And also the turbine control hub can be opened, the components changed while still at sea, and the device deployed immediately. Combined with this operation strategy and reliable turbines, we think we have a bankable product that we can develop very quickly to demonstrate commercial scale tidal energy projects. We're looking at installing mass devices. The one advantage of using smaller turbines is that we have a lot less wake effect than the larger turbines, which means we can get a very, very high packing density and a very high amount of yield. And also particularly where if we elevate the wings, we can get a very high yield, because the high energy is not near the seabed, it's in the mid area. The top area of the sea tends to be very turbulent and difficult, so we're in the right area for that. I'm just trying to sorry, my seems to stuck. So the key advantages, sorry, I need to go back one. The key advantages of this technology is that we can the key advantages of the technology is that we can install at large scale. It's very, very simple in logistics. Our turbines are 12 tons each, can ship easily anywhere in the world, and very, very low cost. I seem to have skipped a few slides here. I'm not sure how I get it to go back. Bear with me. Okay, yeah, so basically the manufacturing costs are very known and understood. We know exactly what it costs to manufacture. We have a really well developed supply chain, and we know the other advantage is with multiple turbines, if one of them does fail, it's not a major issue. The other 5 will continue working, will continue producing power, and it's not, the whole system isn't out, and the turbines can be changed around very, very quickly. One of the key advantages of using a multi-rotor device is fatigue. Large turbines put a huge amount of fatigue through the structure, and it's very, very difficult to get the design life out of the structure. Our jacket structure is made of standard steel components. It's very cheap to produce. It's quite lightweight. Obviously, we have to put ballast in to hold it on the seabed, but that's quite cheap and easy to manufacture. The other key advantage is obviously on the logistics. We can ship the turbines very simple, very, very easily anywhere in the world where we have a project. At the moment, we're developing both a single wing hydro wing and a double wing. The double wing is designed for deeper water, and the height can be elevated without too much effect on the drag to get better yield. And the single wing is used in shallower water locations, typically less than 20 meters. We can operate in as low as 10-meter depths. We're also developing in the future a concept for a DP vessel, which will do when we're looking to industrialize this sector. And this vessel, the concept will allow us to install at scale. We're looking at a single vessel being able to install between 75 to 100 megawatts of tidal capacity a year. And our calculated installation cost is 1/3 of the cost of installing offshore wind turbines. So we're very confident we can compete on the installation cost. The key areas we need to focus on going forward is the manufacturing cost of the turbine, which we believe at scale is easy to achieve, and making sure that we achieve the reliability and the scale that we need to. The key elements we're developing in there at the moment is the turbine control hub, which brings all of the power together, and we're currently designing and will build and test that in Cornwall in our offices there in order to be sure that when we deploy that we can prove that part. It's using all of the same components and or that we use in the OTP project, so that's a great template for us to start on. So that basically brings everything to a close. I think we're, in summary, we're very, very confident we have a strong industrialization strategy. We have the right skills and capabilities in-house. We're very, very open to the supply chain, particularly in Netherlands, where we have our turbine base, to look at manufacturing, and fabrication of foundations for our devices. And also expertise in offshore operations and stuff that we need to do. Okay, that's thank you very much for your time.
Thank you, Richard. We have a question from the chat. The question is, the submerged turbines are not vulnerable to seaweed, fishing nets, ropes, and other types of debris? Question mark.
Yes, we get this question quite often. Over the years, I've deployed many turbines, and I've never ever seen any incidents of fishing nets or debris or seaweed in the devices. I guess in areas of high tidal flow, people very rarely fish, and if there was an issue, we could recover it and remove it simply. So yeah, it's a valid point, but it's not something I've ever seen before.
Okay. Well, thank you very much, Richard. Good to have you on. I think you also came up with a poll question, which comes up now. It's the last poll question. Do you think that tidal energy can provide a significant contribution to renewable energy targets, either in the Netherlands or Europe? It's a yes, a no, or undecided. So please, let's have your votes. Okay. Benjamin, can I invite you to the stage as well? Let me see. Yep, there they are. Well, that's again promising, Benjamin. 74% is convinced that marine energy can play a great part in the energy mix, and in this case, tidal energy. What I would like to suggest now is that we've given you control. So if everybody has a question, please, you can unmute yourself, and we'll just let it go by organically. So the floor is open for questions. You can ask questions to either the presenters, to Benjamin. So please do. I'll start off with the first question. And that's to you, Benjamin. In your story, you told a little bit about European incentive programs. Can you elaborate a little bit more on that? Because I think there's a huge opportunity for companies to step in and make use of European subsidies on marine energy programs. I think the European organization, Ocean Energy Europe, is much involved in that as well. So maybe you can highlight a little bit on these opportunities for subsidy. Yeah, definitely. Thanks a lot, Tjerk. And there are indeed quite a lot of subsidies coming up for the marine energy development and the marine energy sector. And so we will see, so with the new program, Horizon Europe is on the horizon. So it will be launched very soon. We already know that there will be a wave call specifically for wave energy. There will be a tidal call specific for tidal energy. There will be some market calls where subsidies are given. So even in this huge prestigious program, there will be a lot of funding available for marine energy solutions. And I very much encourage the technology developers to apply for that. And also, I very much encourage the entire industry around to apply together, because the industry knowledge on offshore deployments, the industry knowledge on project developments will make a huge difference in making these projects, this European projects, these European subsidized projects, a huge success. Yeah, I think there's a lot of, let's say, potential expertise and know-how in the room, to say it virtually in the room. I would suggest that they contact you, Dmacc. Of course, yeah. You also said something about a marine energy community. Yeah. A Dmacc marine energy community. Maybe you can tell a little bit about that as well. Yeah, so we also, of course, invite everybody who is in here with us today virtually
to apply or to join our DMEC marine energy community. We launched this effort some months ago, and it is really to bring together the Dutch community on offshore marine energy, and also we inform people with a regular newsletter on what's going on new chances, and just keep everybody on date and keep everybody aligned so that we can make a huge difference, in particular here in the Netherlands. So everybody can approach me or just DMEC in general for getting a community member, and we're very happy if many of you join in.
Okay, excellent. I think that's an invitation to all the companies out there. Another question, maybe that's a little bit, it's not to be mean, but I get the impression, looking from the outside, that there's a lot of, let's say, technology innovations, but they more or less have sort of like 80% similarities, and they only are distinctive in 10 to 20% of that specific technology. Maybe that's something that scares off investors or potential partners because they think it's all too, let's say, small. How about, let's say, these initiatives being joined more together so that you have, let's say, more, you can come to economies of scale more easily. Do you recognize that, that people say that?
I think it is a valuable worry in the sector, maybe, or from outside. But I think we have to think back. How did the wind sector, especially offshore wind sector, look 15 years ago? We had a lot of different devices: vertical axis, horizontal axis turbines, a lot of different gravity-based turbines, or the bottom fixed turbines. So we have a lot of, and all day we're just 5 to 10% different. There will be 1 or 2 or 3 which will make it in the end. But I think it's very important that we have these different devices because they actually have a competition in there. And I think it's also good that investors go for different technologies because that will make this competition and in the end make the entire sector more valuable and more valid, because we will really go for the best solution. And the second thing in that regard is also we are teaming up. So that's one of the roles of DMEC, I would say, as well. And also many other projects. You see the Tiger project, which is a tidal project, mainly between the UK and France, where many different tidal developers team up to get the tidal supply chains, for example, working. You see it with Hydroring, Torqado, and in Nyanga with Richard, who gave the presentation today. We work together with SBM Offshore in the same project as we worked with Core Power, another wave developer. So we see this teaming up is happening. And I think it should not happen too much because we still need competition, but it needs to happen to a certain degree to get higher deployment rate or bigger deployment. So I'm completely with you on that, but I think the competition is also important.
Okay, excellent. I don't know whether one of the presenters would like to react on that, on my latest question. Martin?
Just maybe one thing to mention, indeed, I mean, as mentioned by Benjamin, I mean, we are trying, and SBM is not familiar, for example, on the European calls, as we are more familiar with private investment. So indeed, we are trying to team up with various companies within the consortium to apply for funding, European funding calls. And I think in this particular, let's say, sector of wave energy conversion, it's quite relevant indeed to gather forces and expertise.
Okay, that was Ramsey. Martin, you want to add on that?
Yeah, I mean, cooperation, of course, is very important. I think Richard also mentioned some learnings from others in his story. We have similar learnings that make us change tack a little bit on certain aspects. I'm not sure whether I fully agree on your statement that the technologies only differ marginally. I think on certain aspects we differ substantially, and that's driven by focus. Our focus is on lower velocity areas, where, as I tried to explain, you need to cover a substantially larger area because the energy is less concentrated.
Yeah, my question was a little bit to be an advocate of the devil.
That's not a problem.
Get things moving.
So I think the cooperation and learning from each other is very much taking place and increasingly taking place and very valuable.
Excellent. Well, at least offshore energy, in this case, marine energy, has a specific place in the European Green Deal. I think there's a big paragraph dedicated to marine energy, so that's a good point. It's up to, let's say, to us now in the sector to make this happen. Benjamin, do you have questions for the audience or for the speakers?
I don't know, maybe Richard wanted to add something on the last question. I think he also unmuted himself, or?
Yes, certainly. Yeah, basically, I think there's, I don't think any technology in the tidal sector, and certainly not in the wave sector, is totally mature. I still think there's a lot of scope for disruptive technologies. I think that getting investment is a challenge, particularly the scale we're working at. And I think the route to getting investment is demonstrating that we can go to large scale. When I say large scale, we're looking at sort of 50 megawatts in that sort of scale. And then the big boys will want to come and play. But at the moment, we need to demonstrate we can get there. And that's the challenge for us. We need to get to that stage. I mean, if we look at Berghaud is a classic example of a company that went through the valley of death, got a commercial readily product, and failed at that point. So our role now is to pick that up and to get that into commercial applications. I believe that going subsea and being able to mass produce is now our next step in order to attract investment, but it needs to be at a significant, we need to think big to make it happen. You know, we need to be thinking 50 to 100 megawatt scale projects, and then the investment will be there. I'm 100% convinced of that.
Yeah, I think so too. I think Rémi Gruin, the CEO of Ocean Energy Europe, mentioned the same. We need to get scale. We need to get projects of 100 megawatt kicking off. And I think that's the key word. Huh?
I think there it's also back to the entire community, where which was also mentioned in the question, where there was the others and many people project development. I think that's also a sector where the marine energy field can highly benefit of the huge offshore knowledge of IRO partners in terms of getting these projects of multi-megawatt scale into the water, and not just getting one little device into the water, but getting really an area of devices into the water. And whenever there is project development incentives of any of the partners, please also reach out to us, and we are happy to work together with you to get them or to make these projects then reality, to bring the right marine energy developer in there and build an area.
Excellent. Well, we have teamed up, DMEC and the IRO, so we'll do anything in our power to give marine energy a boost. We have almost 400 company members, and I think we're on the right track now. So let's keep doing that. If there's, we were a little ahead of time, but that's okay, I think. I want to thank all the speakers, Richard, Maarten, and Ramzi for joining us and telling your story. I want to thank you, Benjamin, for being here and elaborating on marine energy in general.
Thank you for the invitation.
Just hope I wanted to show the slide of the Academy. Can you? Yes, this one. We're here because I didn't mention it yet, but this is actually the old library academy in Delft, where we have had this webinar. An excellent place. I've mentioned quite a few times in the past already, but it's a beautiful place, and they do webinars like this, studio facilities, they have it all. So please, if you have any questions, go to Desiree. You can't see her, but she's here, and she'll be happy to answer your questions. It's been a pleasure. Thank you very much for joining us. Normally, I would say have a safe trip home. In this case, I would say stay safe and see you next time. Bye-bye.
Okay, thank you. Bye now.
Bye-bye.
Bye.